Query Optimizer uses heuristic algorithms to evaluate relational algebra expressions. This involves estimating the cost of a relational algebra expression, transforming one relational algebra expression to an equivalent one, choosing access paths for evaluating the sub-expressions. Query optimizers do not optimize, just try to find reasonably good evaluation strategies. Query evaluation problem. An SQL query is declarative, does not specify a query execution plan. A relational algebra expression is procedural. There is an associated query execution plan. Solution: convert SQL query to an equivalent relational algebra and evaluate it using the associated query execution plan. Equivalence preserving transformations. To transform a relational expression into another equivalent expression, we need transformation rules that preserve equivalence. Each transformation rule is provably correct, that is, does preserve equivalence, has a heuristic associated with it. Selection and projection rules break complex selection into simpler ones. Cond1, Cond2, R, Cond1, Cond2, R. Break projection into stages. ATTR, R, ATTR, ATTR, R. If ATTR, ATTR commute projection and selection. ATTR, Cond R, Cond ATTR, if ATTR all attributes in Cond. Commutativity and associativity of join, and Cartesian product as special case. Join commutativity, RSSR, used to reduce cost of nested loop evaluation strategies. Smaller relations should be in outer loop. Join associativity, RST, used to reduce the size of intermediate relations in computation of multi-relational join first compute, the join that yields smaller intermediate result. N-way join has TN n exclamation point. Different evaluation plans. Tn is the number of parenthesized expressions. N exclamation point is the number of permutations. Query optimizer cannot look at all plans. Might take longer to find an optimal plan than to compute query brute force. Hence, it does not necessarily produce optimal plan 9. Pushing selections and projections. Cond R, S, R. Cond S, Cond, relates attributes of both R and S. Reduces size of intermediate relations, since rows can be discarded sooner. Cond RS, Cond RS. Cond involves only the attributes of R. Reduces size of intermediate relations, since rows of R are discarded sooner. ATTRS, ATTR, ATTRRS. If attributes R, ATTR, ATTR, attributes R, reduces the size of an operand of product 10. Equivalence. Example, C1, C2, C3, RS. C1, C2, C3, RS. C1, C2, R, C3, S. C2, R, C1, C3, S. Assuming C2 involves only attributes of R, C3 involves only attributes of S, and C1 relates attributes of R and S.